Chapter 14 and 15 are going to be covering the later part of our life, as many people like to call it, our senior years. Demographics is the study of how people change across time within certain societies. In healthcare, we do a lot of demographic studies. And the reason for this is that we need to understand how our current environment is changing. So, what is the population going to look like today? What's the population going to look like 5 years from now, 10 years from now? If we have a lot of young people, let's say between 16 and 18, or let's make it even younger, 10 to 18, we can predict that that number of people have a potential for having babies between the ages of 20 and 30. So we kind of might know how many babies we have coming. If we have a lot of people between 50 and 55, or between 50 and 60, let's say, in the next 10 years, we can predict how many people we're going to have between the ages of 60 and 70 and the type of healthcare that they're going to need. So demographics is something that we study an enormous amount here in healthcare, especially if you decide you want to go into public health. It is how we determine the number of beds that we have. It is how we determine how many doctors really can suit an area, how many nurses we might have. Demographics is extremely important within understanding the availability and the potential for delivering healthcare needs to basically our entire society. It isn't just about aging. It isn't just about seniors. We got to look at the demographics of how many young kids there are so we can determine how many elementary schools we might need, and how many middle schools, and how many junior high schools or high schools we might need. So demographics is actually something that we take a look a lot at here in pretty much all medical fields, including psychology and physical. You would think that talking about longevity would be pretty straightforward, but it's not. Here we have three different ways to look at longevity. I think your textbook might even have four different ways to look at longevity. So, maximum life expectancy is what is a life that any human could have? What is the maximum life that potentially a human can have? So right now, we're saying maybe about 120 years could possibly be the longest right now. That means that somebody born already, they might even be only a year or two, might make it to 120 years of age. And we've had some pretty long living people, but as you know, that's a rarity. But that would be the maximum life expectancy. Whereas useful life expectancy is the number of year a person lives from any kind of debilitating or chronic disease. So, if you develop Alzheimer's, as we're going to talk about later, that's a chronic disease. The question is how many years might you live before you develop something such as that? Average life expectancy is what you generally hear people talk about. What's your average life expectancy? Now, one of the keys here, and we tend to forget this in the definition, is that it is basically half the people are still alive that were born in a particular year. So half of the people born in a particular year will have died. So when we say the average life expectancy of a woman, let's say, is 80, what we're saying is that when she was born, 80 years later, half the people who were born are still alive. So if there were a million people born, there's only 500,000 people now. That's 500,000 people who are 80 years of age. We tend to think if you've made it to average life expectancy, you've done really well. Not really, you've done on average because half of the people born have already died. So a lot of people died in infancy, some people died in their 20s, 30s, 40s, and so on and so forth. So what we're basically having is a lot more seniors than most people tend to think. If we're looking at average life expectancy as being 80, that means half the people born 80 years ago are still alive. One of the interesting statistics that I read not too long ago said that if you make it to 65 relatively healthy, doesn't mean perfect, but relatively healthy, that on average, people live another 20 years. So if you make it to 65 without too many debilitating diseases, the basic ones of old age, then you're probably going to make it to 85. And that's half the people who make it to 65. So again, if we have 2 million people who've made it to 65, that means at 85, we're still going to have 1 million people alive. That's a lot of seniors if we start thinking about the baby boomers. Also, the other thing I kind of throw out to you, since most of you sort of expect to be somewhat healthy at 65, have you saved enough money to live another 20, maybe even 30 years beyond retirement? It's one reason why people in the finance world constantly are asking you all to start saving money and start thinking about your retirement. You may be retired for as long as you have worked for some of you. You work for 30 years and then you're retired for 30 years. So, one of the things that also asks is it genetics or heredity that tends to make a difference in our livelihood, you might say? Heredity seems to be the biggest thing as far as longevity, especially those who've lived to be 100. And I love these pictures because they have these people who tried to pose exactly like they did in these pictures they have of themselves. We do know, though, that environmental play has come in. Things such as smoking and other risky behaviors, toxins that might be in the air, certain diseases that go around may also result in certain areas having death. As a good example, in Utah, there's a very high risk of breast cancer and breast cancer deaths. And yet, they don't have the disease, they don't have risky behaviors, they're actually very healthy as far as women are concerned. But in this case, it's toxins because of the radio fallout from the nuclear testing that was done. There are huge clusters of breast cancer in Utah. So we have to also understand there are going to be some things that are in the environment that could affect longevity, but most of it actually is going to be heredity. Gender does make a difference in your life expectancy. Women in general live longer than men, and as you can see by this slide, at birth we live about 5 years longer than men if we're going from birth to average age. If, though, both people make it to 85, then basically a woman's only going to outlive the man by about 1 year. So that's why this may look a little bit disconcerting at first. So from birth to average age, that's 5 years. But if they both make it to 85, the woman will probably make it to 86. One thing we do need to think about, though, is why are our senior centers and our assisted living homes and our nursing homes just full of little white hair women? Well, it's pretty easy because we do say that women tend to outlive men by 5 years. So let's say that we have a married couple. She's 70 and he is 75. I guess I should use two different colors. Now, he dies, unfortunately, at 75. So she's got 5 more years to hit to get to be 75. That would be equal to when he died. But because she lives longer, she's probably going to live to be 80, which means that she has outlived her husband by about 10 years. And on average, that's what we see. Older women will outlive their husbands by about 10 years. Your book goes into some of the biological theories of aging, and a lot of this is very easy to read and go straight through. So I'm not going to spend a whole lot of time on it because a lot of these questions that you're going to have coming up are going to be basically kind of fact-based questions. So the rate of living theory basically says that when we are born, our metabolism is already sort of preset. Our metabolism gets slower as we get older, and basically we are not going to be able to reproduce our cells at a good rate. Now, the cellular theory is kind of one that is pretty interesting, and that's what this chart is basically talking about. Basically, we're talking about these things called telomeres, and as you get older, those get shorter. The shorter they get, the more trouble you have with aging. It is also perhaps what is directly related to things like getting wrinkles or metabolism rates, and there are even now tests you can take to figure out how short or how long those are. And the last one is program theory. Now, program theories basically says that we're pre-programmed with how long we're going to live. That kind of goes back to genetics, meaning is that your genetics have already said that your family is going to be a long living family, lots of people who are going to make it to 100, or most of your family is going to die in their 70s. So what we find is probably it's going to be a combination of these when we talk about aging. And when we talk about aging, we're not just talking about the age of death, but we're also just talking about the whole body aging. Why do our faces change? Why do our insides change? And all those type of aspects that we deal with the aging body. Physiologically, we also have changes in our brain. Now, the big thing that we're going to see is this plaque and this tangle. Now, I like this particular picture. It is talking about Alzheimer's, and we'll come back and talk a lot more about Alzheimer's. But what we're talking about is that as we age, here in this figure B, what we're going to see is that we start to develop these tangles right through here. And basically, within the neurons, these complex webs begin to occur. We also will find that plaque will begin to occur. And as that plaque begins to occur, what can happen is that the brain basically begins to disintegrate. And that's why we see with some very severe Alzheimer's, it's why people have problems with cognitive areas with Alzheimer's, because basically they don't have a healthy brain anymore and parts of their brain are missing. But even if you don't have Alzheimer's, everybody's going to have some tangles and some plaque that builds up. No matter what, this tangle and plaque can make it much more difficult for seniors and for older individuals to think and process as clearly. Now, let me make sure that I make this clear. First of all, not everyone's going to develop the same amount, and we don't instantly have it at 65. 65 was just an age that was picked as a retirement age because of the development of Social Security. They basically picked 65 because they had figured out how long someone might live past that. But that's not an official body type thing, not in physiological terms. It is more as far as a work life sort of term. So we may really be talking about 70, 75 when we start seeing these types of things. Also, again, it depends on your genetics. Cardiovascular and respiratory systems becomes your next one. Again, pretty straightforward information, but one of the ones I do like to talk a little bit about is vascular dementia. And the reason I like to talk about vascular dementia is because of the word dementia. People tend to think that if it's dementia, then it must be a brain related problem. And yes, it is. But we're going to find that dementia is a category of diseases. There are many diseases, but yet this isn't listed under dementia. This is part of the cardiovascular system. And if you know, cardiovascular system deals with blood flow and the ability for blood to basically get around the system with your heart, your capillaries, veins, arteries, that type of stuff. So if we're talking about vascular dementia, we must be talking about something that happens in the brain. And that's what's nice about this particular model over here. What they're trying to show you is the difference between Alzheimer's disease and the vascular dementia. Alzheimer's has to do with those tangles and neurons we talked about and the actual brain sort of disintegrating, where vascular dementia has to do with the ability of blood flow through the brain. Now, when the blood flow through the brain is disturbed or it has too much, it can make us appear to have dementia because we have the inability to remember things, we have the inability to function. We can also find that the brain could have little bleeds all over. That's a vascular dementia. And when these little bleeds occur, again, we have this issue with having the ability to think and actually control sometimes even motions, but it's not Alzheimer's and it is not a dementia specific disease. It's actually a cardiovascular disease. So it's kind of an interesting one and one you might want to take a look at if you ever have to do a comparison, compare vascular dementia to Alzheimer's disease. Parkinson's disease is caused by this deterioration of dopamine production in the midbrain. So people have Parkinson's, and there have been some very famous people who have Parkinson's, have a variety of symptoms. There are some that seem to be directly related to the reduction of the dopamine. There also seem to be hypothetically, no, not hypothetical, hypothesis. See, it is hard to say that word when you're in the middle of a conversation. The hypothesis is that some Parkinson's disease can also be caused by injury. So, having brain injury, such as boxing or football, can injure that area of the brain that produces dopamine. Now, in other cases, there may not be any head trauma and it could just simply be a disease within the brain. Either way, we do know that most people are going to suffer some sort of cognitive impairment and unfortunately, eventually, some sort of dementia. As you know, there are several people who are famous who've had Parkinson's, and they are working really hard on trying to find ways around it. What is good is that they do know if they raise the dopamine, that can help the brain at least function, but it doesn't mean that it's going to stop or cure the Parkinson's disease at this time. Vision changes. Anybody who's dealt with somebody who's older knows that there's going to be some vision changes. And even if you're younger, you're going to have some vision changes. Even by the time you're 20 years old, we can expect to begin to see some difficulty with low light vision. By the time you're 60, have fun. Now, the one that I want to talk about specifically is AMD, or what they call age-related macular degeneration. Now, the reason I want to talk about that one is that it's one that we're going to see far more often in our population and one that people have very little knowledge of. Now, there are two types of age-related macular degeneration. There's what's called the wet and the dry age-related macular degeneration. Basically, the macula is this little area right here that's right by the optic nerve. And what happens with macular degeneration is that basically that area begins to have problems. And basically it begins to disintegrate, which is why they say degeneration. Now with dry macular degeneration that we see right here, basically we're going to get little dry patches that sort of begin to disintegrate that macular area. With wet macular degeneration, what actually begins to happen is that we begin to get some bleeding right here. And when we get the bleeding in there, it actually destroys the macula again, making it very difficult for someone to see. So with macular degeneration, what you get is sort of this kind of curvy area, you might want to say. So you may have seen one of these grids before where basically they've got these lines that go one way and the other way. That's a pretty crooked line. And it's got a little dot in the center. What they ask people to do is to take a look at that dot. Just keep, every once in a while walk by and take a look at it. When you begin to see that dot waver, then you may have the beginning of macular degeneration. And over here in the second image, you see basically a very strong macular degeneration. Now, what does that mean? Well, that means is that your vision right in the middle of your eye is going to basically begin to go away. Now, these people never go totally blind, but it's almost as if they were blind because as the macula gets more destructive, a larger black spot will occur in the middle of the eye. They might see way off in the corner of their eye or way off to the side, which is why sometimes people with macular degeneration, when they want to look at you, won't look at you. They'll look to the left of you or look to the right of you because they might have still a little bit of vision on either side of the eye. Now, macular degeneration is absolutely age-related, meaning is that we see most of it happening when people get to be older, 70. It is also surprisingly ethnically there, and it is something that affects white Americans more than African Americans. Asian Americans are just a little less than Caucasians, and then Latinos. But there's also a gender to this. So white females are going to be the most likely to have age-related macular degeneration. About 35% of the population of women of the age 70 or above will have macular-related degeneration, AMD. So that is something to think about as you begin to deal with older individuals. If they're having difficulty seeing something, it doesn't mean to raise your voice, which I hear way too often. But what it may mean is that they will need assistance in filling out forms. With a lot of things these days, we are asking people to fill out forms online, which people with macular degeneration can't do, or we hand them a tablet and we ask them to fill in their information from the tablet, and they can't do that. A lot of people who have AMD have learned to live in their world through feel, just like a blind person. And as AMD gets progressive, they become more and more just like a blind person. So when you go to the store and they pick up whatever it is that they want to pick up, and then the nice little clerk says just push the green button. Well, they can't see the green button and they go to feel for the button, but there's no buttons because the buttons are on a screen. And if we can't see the screen, then how do we see the buttons? Not only that, as you see, we begin to develop a difficulty with blue-green color variations. And so when you're asked to pick something out like a green button, you may be seeing only black and white at this point or shades of gray. So the red button and the green button look the same. It really is going to become an issue as we have more and more of our baby boomers getting older and they develop AMD. Now, the loss of hearing is basically something that's going to happen to all of us. What I really love is this chart because basically you can see by the time you're 90 years old, you are losing a lot of high pitch hearing. Now, what we mean by high pitched sound is we're talking about basically the hertz. And even by 20 years of age, you can see that you've lost a little bit right here. So what is interesting is that if we were to take an 8-year-old and play something that's at the 8 kilohertz, an 8-year-old could hear it, but a 20-year-old couldn't, which is one reason why anytime I have a little kid tells me that there's some annoying sound, I always believe them even though I might be young, because I realize that they can hear things we simply can't hear. When it comes to diabetes, most of us know there are two types, type 1, type 2. The way I always remember type 2 is that you're too fat. And it's more than just simply being too fat, but that's what we tend to talk about. And as you can see in the chart, there's a lot more type 2 diabetes than there is type 1. Now, there is a third type of diabetes, which is basically women who are pregnant who get elevated glucose levels during pregnancy. But for most of us, we tend to think of only type 1 and type 2. Those of you who are going into the allied health fields, you'll might even discuss up to 5 different types of diabetes. But for us, for this class, type 1, type 2, and remember type 2 is because you're too fat. As I always like to do, give you little hints to help you remember things. Information processing, no surprise, we get a little slower as we get older. Now, in part, this is due to the decline of white matter in our brains. The white matter helps us process faster. And as you have less white matter, it's going to take you a little longer. You also have some tangles and you have some plaque. So all of those things are there. But there is a difference between slower processing and stubbornness, you might want to say. Slower processing simply means I might take me a little bit longer to gain the information that you're telling me and for me to process that information. Now, one way you can help people who are a little older is not to suddenly speak louder. That isn't going to work. If they can hear, they can hear. If they can't, they can't. But instead, focus on doing sort of this stutter speaking where you have little pauses in your speaking, like I'm doing now, to allow the brain time to process that information and get it in. If they have the time between words and little phrases to process the information, they can do just fine. But what happens is that you're a mental health professional, and you walk in the room, you've already said the same speech to 5 other people, and all you can think about is that your doctor is asking you to speed it up because you're already running about 15 to 20 minutes late. And suddenly you get in and you start talking at this speed, and here's what we want you to do, and then go ahead and take this, and we've called you blah, 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 blah. And the poor people have totally lost you. They have no idea what you're saying. So it's really important that we give them the moment that they might need to process the information. It doesn't mean that they do not have intelligence. But if you speak too fast, it simply won't get in. And some of you may have found that I speak really fast and you have to go back and listen to the information again. Well, if you're thinking I'm speaking fast and you're pretty young in your brain, can you imagine what's going to happen for a brain that's a little bit older? It's going to take a little longer for them to process the information. The one thing you do have to remember, though, is that this processing speed probably doesn't really see a dramatic drop until your 70s. Up until about 70, most brains are handling this stuff pretty easily. However, many people think that older people are stubborn or that they just simply can't grasp the new information. A lot of times that is not true. What's actually occurring is that you haven't convinced the older person to make this change. So if you think about this for yourself, and the women will get this, we go out and we have this wonderful lipstick we love, and then we go to the store and suddenly that lipstick is discontinued. Do we jump up and down for joy and say, yay, I get to find new lipstick? No, we curse and say, why did they stop making it? And we're pissed. Or you start heading home and they've closed the road and they make you take another way to get home. Even though this other way may be a little faster or exactly the same time, you're not happy. You don't like going this way. You have a way that you go. For a lot of people, by the time you get to be an older individually, you might want to say you're set in your ways as much as we've already figured out what works for us and we don't want to change it. Most people will not make change unless they see a reason to make change. So it becomes really important to explain the reason for the change. And then sometimes it's just simply to say, you know what, you're correct. I don't think the new meter is something that you should be happy about. However, your insurance company won't pay for the old meter. And so we have a choice. You can pay out of pocket for the little, I don't know what it might you need for your meter, but the little utensil you need for the meter, or you need to change to the new meter so that your insurance company will accept it. It kind of sometimes comes down to that. But don't think that just because somebody may not want to change, that means that they don't understand the change. When it comes to memory, there are four types of memory, you might want to say. There's two large categories, explicit and implicit. I'm going to start with implicit, even though it's on the last one here, because basically it's the easiest one, I think, to understand. Implicit is something that just pops into your brain. Maybe you're driving down the road and all of a sudden a memory of a Christmas past comes into your brain. And you might even go, how in the world did I even think of that? I don't even know what made me think about that past memory. That's an implicit memory. It's basically automatic. It's unconscious. You didn't try to bring it up. It just popped into your head. Explicit memories, the first one, is deliberate. So these are ones like you do for the test when you read something and you try to remember what it is that the question is asking. Now, there's generally two types that they're going to be asking you for. One is semantic, so you're trying to remember the meaning of the word. You read the question and you say, what does that word mean? And then there's episodic, which is recalling the information. So when you did your chapters in Introduction to Psychology about memory, you sort of learned that we're going to pull information out of long-term memory and bring it back to short-term memory. And we often do that through recall or recognition. But both of them, you need to be able to recall, let's say, some information. You have to be able to recognize what the words mean. And that's going to be that crystallized memory that you're going to get better as you get older. And then you're going to have to try to relate that information back to some episode or something that you remember. I bring this slide in, not that creativity is something you're going to have to know for your test, but I do think that when we're talking about aging, that creativity is kind of an interesting thing to look at. Now, what you're seeing here is when people tend to be at their most creative. Now, creative means to be able to produce work in a novel way. So if I write a song, that's being creative. If I sing somebody else's song, that's not being creative. That's somebody writing and me just interpreting. Me drawing an original picture is creative. Me copying a master is not creative. But what this basically shows is one of the interesting things is that, first of all, we already kind of knew that creativity is sort of at its peak around year 35. So between 30 and 40 is when most people are at their peak, except for the fact that it's sort of changed. That what we're seeing is that creativity, as we have moved through the years, has really sort of shifted. So right here, after 1965, before 1935, and between 1935 and 1965, that's what each one of these little lines show. So since 1965, we can see that the most creative time in people's lives tend to be a little bit later than they were before. So if I draw that same line straight down here from, I'm going to do my best to be straight from the green line, we can see we're getting more toward our peak in almost closer to 40, whereas in this first one, which was before 1935, and again, this is sort of an estimate, the best I can do with drawing a straight line, we can see it was closer to 35. Now, this is based on Nobel Prize winning and some other things that they've got that they can measure this with, and we look at that as being creative. It is interesting that as we have aged, or as our society has aged, we have found that our creativity comes a little bit later. There's all kinds of hypotheses on why that is, but the other interesting thing that has occurred, and you might not have noticed that when you first looked at the curve, but is the actual shape of the curve. So if you kind of look at this one, and you look at the shape of that one, now I'm going to take that away so you can see the shape of the other one. You can see that the shape of the one that's more today is much wider. So we have a longer period of creativity, you might want to say. So if we want to talk about people being highly creative, if we're looking at, let's say, this 0.3 line, and we look at our first group, we can see it ends here. But with the more current generation, we can see it's almost till we're 50. So the good thing is you're living in a day and age when your creativity is still relatively there. You're probably on the downslope once you get to be about 50, but we still have a lot of creativity in us. Unfortunately, one of the things that really hit seniors and our older individuals is depression. Now, while it says it's 9% in younger adults compared to 14.5% in older adults, 13% of older adults, though, who have some sort of home health care are going to show signs of depression. Unfortunately, of that 13% of adults who have depression, only about 40% are going to get some sort of treatment. In part, there's lots of reasons for this. We do have maybe the stigma of depression with people who are older because they grew up in a time where people didn't have mental health problems. But we also have the problem in that we tend to say, well, yeah, we can understand why they're sad and depressed because they're older and they can't do what they could do before. The thing is that they still have problems with neurotransmitters, and if they are having problems with any kind of brain issues or other issues that deal with the brain, we may see that levels of serotonin aren't at their proper levels, or levels of dopamine are too strong. So they really do need to get treatment, but they should get treatment from somebody who specializes with the aging, because the brain and the brain chemistry is so much different when we're talking about a 70 or an 80-year-old than we are when we're talking about a 40-year-old. Alzheimer's is a disease of dementia. Now, we have many diseases of dementia. The reason that we bring Alzheimer's up front is because it seems to be one in which we have a lot more discussion about. Now, we do know that Alzheimer's can have two types: early onset Alzheimer's, which is a genetic one that we can pretty much diagnose early on. And then we have sort of the more normal Alzheimer's, you might want to say, which comes on a little later in life. Unfortunately, right now, we don't really have a great way to test whether or not you actually have Alzheimer's. And the other interesting thing is that when it comes to risk factors, there are some genes that apparently hurt us and some genes that apparently help us. So that's not so good either. But the genes that we do know that tend to increase Alzheimer's are ones that we can test for. But remember, we also tend to have genes that might reduce our risk factors. So genes could help or even hurt us. So, how do we know that somebody actually has Alzheimer's? We're only going to know after an autopsy. Unfortunately, before that, we don't really know if it's truly Alzheimer's or if it is another type of dementia disease, because there's more than one type of dementia disease that might shrink this gray matter that we talk about so much. So it is kind of unfortunate. Now, what we do most of the time these days is that we give it a try. Basically, we look at some neurological testing, we do some medical testing, we do some scans, we look for behavior symptoms, and then we give them medication. If it seems to be working, we're going to assume it's Alzheimer's and we're going to go forward from there. Really, with dementia diseases, the variety of them. If the medication works for Alzheimer's, it could also work for 2 or 3 other types of dementia diseases. It is getting better at making those diagnoses as we begin to get better imaging. The question, though, does come down to just how much do we really want to get into this as far as the diagnosis is concerned. What they're really looking at more is trying to find factors that can help stop Alzheimer's or slow it down. If we can slow down the Alzheimer's, we may not be able to stop it because the brain is going to age, but slowing it down might allow someone to have a more successful senior life. So this is the end of chapter 14, and as normal, if you have any questions, you can contact me at ramonab@kaiseruniversity.edu, and we will see you in class.